Under mountains, in jungles, and across windswept plains stand structures so massive and so precise that they feel entirely out of place in the ancient world. We find stones weighing hundreds of tons, carved as if they were soft clay, and passageways cut into solid rock with glass-smooth surfaces that defy the primitive tools of the era. These are the megaliths, physical relics from a time when someone, somehow, worked stone on a scale that modern engineering still struggles to explain. In this video, we focus on 10 of the most extraordinary examples ever built, and when you look at them together, one question becomes hard to ignore. Did the people who built these monuments know far more than history admits? Or are we missing an entire chapter of the human story? And before we start, while the visuals are there for context, they aren't necessary to enjoy the journey. The stories and the scale of these structures speak for themselves. So, sit back, relax, grab a snack, and join us. And if you enjoy deep dive documentaries like this every single week, make sure to subscribe. Now, let's get started. High on the sun-bleached ridges of the Jahanabad district in India, the landscape is dominated by massive, weathered outcrops of Precambrian granite. From a distance, these hills, known as Barabar, look like the jagged spines of a buried creature worn down by eons of intense heat and environmental exposure. To a casual hiker, they appear to be a standard geological formation, but these ridges hide a series of chambers that present one of the most difficult engineering puzzles in the archaeological world. When you step inside the Lomas Rishi cave, the transition is immediate and jarring. You leave behind the rough, uneven texture of the natural mountain and enter a space defined by absolute geometric precision. It is a void hollowed out of one of the hardest stones on Earth, finished with a surface so smooth it mimics the texture of liquid glass. The technical gap here is difficult for modern researchers to reconcile with the established timeline of the region. Granite measures a 7 on the Mohs scale of hardness, meaning it is second only to materials like topaz, sapphire, and diamond in terms of structural resistance. Yet, the interior walls of these caves are not just smooth, they are polished to a reflective mirror finish that hasn't dulled or eroded in over 2,300 years. Even in low light, the walls catch the glow of a torch with the clarity of a modern optic. Officially, the archaeological community attributes these structures to the Maurya Empire during the 3rd century BC. We are told these were the work of Iron Age laborers serving Emperor Ashoka to provide a permanent home for the Ajivika sect, but the physical reality of the stone raises significant questions about the tools available during that period. The primary issue is the toolkit of the 3rd century BC. To date, no archaeological excavation has found a tool from the Maurya period that is actually capable of achieving this specific mirror polish on a curved granite surface. The standard historical theory is that thousands of workers used iron chisels and stone hammers to peck away at the rock, followed by months of hand sanding with abrasive sand and water. However, engineers often point out that hand sanding is an inherently imprecise process. It almost always leaves behind slight waves or irregularities in the stone. In the Barabar Caves, the walls are flat to within a fraction of a millimeter. The symmetry is so exact, it suggests a level of precision we usually associate with mechanized grinding, a process that removed hundreds of tons of granite without leaving behind a single visible tool mark or error in the primary chambers. The history of the site is tied to the Ajivika, an ancient school of Indian philosophy that was a major rival to early Buddhism. While the inscriptions on the Sudama and Lomas Rishi caves explicitly state they were gifts from the Mauryan crown, there is a noticeable qualitative gap between the text and the stone. The inscriptions are relatively shallow and crude compared to the masterful engineering of the chambers themselves. This discrepancy has led some researchers to investigate whether the Mauryans were the original builders or if they were repurposing a site that had already been established. While mainstream archaeology holds firm that the Mauryans were the architects, The lack of any practice sites or evolutionary steps in masonry at the location makes this a unique, isolated peak in Indian architecture. Beyond the visual perfection, the true anomaly of Barabar is the acoustic engineering. These were clearly not intended to be simple living quarters or storage units. They are resonant chambers engineered with a mastery of physics that feels remarkably advanced for the era. Standing in the center of the Sudama or Lomas Rishi caves, even a whisper is captured and amplified by the stone. A low-frequency hum or a sharp clap creates a reverb that can last for several seconds, bouncing off the polished granite walls with a clarity that can be disorienting to the human ear. This wasn't an accidental byproduct of hollowing out a mountain. The specific elliptical and circular geometries of the chambers suggest that acoustic resonance was a primary design requirement. Researchers have explored the idea that the builders understood the piezoelectric properties of quartz-bearing granite, the phenomenon where physical pressure or vibration on the stone can generate a small electrical charge. By carving these specific shapes into the bedrock, they created a space that interacts with sound in a highly specific way. The hollowing of these hills was a massive logistical effort to manipulate sound waves, likely for specific ritualistic or physiological effects on the human mind. While we are only just beginning to understand the relationship between stone resonance and neural activity, the evidence at Barabar shows that someone 2,300 years ago was already mastering these principles in the middle of the Indian wilderness. The archaeology of the site is further complicated by the total absence of a learning curve. Usually, when a culture masters a new skill, we see evidence of their progress nearby, cruder, smaller versions where they practiced their craft. At Barabar, there are no practice caves. The work begins at a peak of perfection. There are 4 caves in the Barabar group: Karan Chaupar, Lomas Rishi, Sudama, and Visvakarma, and 3 more nearby at Nagarjuni. Each one displays the same impossible finish. Even the unfinished Lomas Rishi cave reveals an unsettling detail. The work was abandoned halfway through the entrance carving, yet the interior parts that were finished are already polished to perfection. This implies that the polishing may not have been the final step of a long process, but perhaps part of the primary carving method itself. When you try to replicate this work with the tools assigned to that era, the official history faces a serious challenge. Iron Age chisels are effectively useless against the compressive strength of granite. They blunt and break almost immediately. To get a mirror finish on vaulted 3-dimensional surfaces requires high-speed abrasive friction that modern engineers would only attempt with specialized grinders. Furthermore, the sheer volume of granite removed is staggering. We are talking about hollowing out chambers 30 feet long and 20 feet high directly into the heart of a mountain. But where did the waste material go? There are no massive piles of granite chips or rubble surrounding the hills, leading to questions about how hundreds of tons of stone were managed and removed from the site. In conclusion, while mainstream history attributes the Barabar Caves to the Mauryan Empire, the physical evidence continues to spark debate among engineers and archaeologists alike. The crude nature of the inscriptions compared to the masterful engineering of the chambers suggests a level of technological dissonance that is hard to explain. We are left with 2 possibilities. Either the Mauryan laborers possessed a lost technique for working granite that has never been found in the archaeological record, or they were utilizing structures that belong to a much older, highly advanced tradition. Regardless of which theory you subscribe to, the Barabar Caves remain a reminder of a peak in human capability that mastered stone and sound in ways that still baffle us today. Deep within the Yangshan Mountains near Nanjing, China, lies a site that redefines the concept of monumental scale. To put it into perspective, the largest blocks used in the construction of the Great Pyramid of Giza weigh roughly 80 tons. While impressive, they are practically pebbles compared to what sits in the Yangshan quarry. Here, 3 massive components of an unfinished stele remain partially attached to the living rock, abandoned centuries ago. The largest of these pieces, the stele base, is estimated to weigh a staggering 16,000 tons. If it had been completed and assembled, the monument would have stood nearly 250 feet tall, a stone structure taller than a 20-story building carved from a single mountainside. The project was commissioned in the early 15th century by Emperor Zhu Di, the third ruler of the Ming dynasty, who reigned from 1402 to 1424. Zhu Di, also known as the Yongle Emperor, was one of the most powerful and ambitious figures in Chinese history. He came to power after a bloody 3-year civil war against his nephew, and much of his reign was dedicated to proving his legitimacy and projecting the absolute power of the Ming throne. This was the same era that saw the construction of the Forbidden City in Beijing and the launching of the massive treasure fleets under Admiral Zheng He, which sailed as far as Africa. The Yangshan stele was intended to be the centerpiece of this imperial branding, designed to honor his father, the Hongwu Emperor, at the Ming Shaoling Mausoleum. Life during the early Ming dynasty was defined by a strict social hierarchy and a massive mobilization of labor. For a project of this scale, the Ming state would have conscripted thousands of specialized stonecutters, engineers, and general laborers. Archaeological records and local chronicles suggest that the working conditions at Yangshan were brutal. It is estimated that thousands of workers died during the excavation process, succumbing to the sheer physical toll of carving granite and limestone with manual tools, or killed by falling debris in the deep, narrow channels. These laborers lived in temporary camps near the mountain, and their primary tools were iron chisels, heavy sledgehammers, and bellows-powered forges used to constantly resharpen their equipment. The engineering reality of the 1400s makes the official story that they simply changed their minds highly suspect. To move 16,000 tons, the Ming architects would have needed to construct a roadbed virtually as hard as the stone itself to prevent the block from sinking into the earth. Even at the height of their technological prowess, the Ming did not possess high-tensile steel cables or hydraulic lifting systems. Historical records mention the use of ice roads for moving heavy stones to the Forbidden City, where water was poured onto roads in winter to create a low-friction surface. However, the weight limit for an ice road is calculated by the thickness of the ice and the structural integrity of the soil beneath it. Moving a 16,000-ton base would generate enough pressure to instantly liquefy ice and collapse any timber rollers or sledges used in the process. The quarrying process itself was a feat of subtractive engineering. Laborers had to cut vertical channels into the mountain that are over 40 feet deep and only a few feet wide. This created a claustrophobic and dangerous environment where heat and dust would have been constant. The stones were isolated from the bedrock by cutting underneath them, leaving only small pedestals of stone that would eventually be snapped to free the block. In the stele body, which is a rectangular slab 160 feet long, we can see the sheer precision of these channels. There is very little evidence of overcutting or structural cracking, which suggests the Ming engineers had a highly disciplined method for managing the internal stresses of the rock as it was being separated from the mountain. Archaeologists have identified massive bosses or protrusions left on the sides of the stones. These were not decorative, they were functional. In ancient masonry, these lugs served as anchor points for ropes, levers, and pulley systems. The presence of these bosses indicates that the transition from carving to moving was already being planned in detail. However, the sheer mass of the stele base, measuring 30 meters long and 16 meters high, meant that even with 10,000 men pulling in unison, the force required to overcome static friction would likely exceed the breaking point of any organic rope material available in the 15th century, such as hemp or braided bamboo. The project was officially abandoned in the 6th year of Yongle's reign. While the mainstream narrative cites the logistical impossibility of the weight, some historians point to the massive shift in the empire's priorities. In 1421, Zhu Di officially moved the capital from Nanjing to Beijing. The focus of the empire's resources shifted to the construction of the new capital and the defense of the northern borders against Mongol incursions. The Yangshan quarry was left as it was, a half-finished skeleton of a monument. But this raises a deeper question. Why was such an obviously impossible task started in the first place? Ming engineers were world-class experts in bridge building and canal construction. They would have known the weight limits of their infrastructure. The scale of Yangshan suggests it was an attempt to replicate or even surpass the megalithic feats of earlier dynasties, or perhaps even lost pre-dynastic cultures. We see 800-ton stones moved in Baalbek and 1,000-ton obelisks moved in ancient Egypt, yet by the 1400s, the Ming engineers, despite their advanced mathematics and massive navy, could not complete the task. This proves that by the 15th century, the specific heavy lift technologies used by earlier megalithic builders had been entirely lost to history. The Yangshan Quarry isn't just a failed monument. It is a documented record of a civilization reaching for a level of technology they no longer possessed. Archaeological surveys of the surrounding Yangshan area have failed to find the massive amounts of debris one would expect from a project of this size. While some of the waste rock was likely used for the nearby Ming Xiaoling Mausoleum, the sheer volume of stone removed to isolate these three components is estimated in the hundreds of thousands of tons. This suggests a highly organized waste management system that treated the quarry as an industrial factory. The site remains the largest example of unfinished megalithic work in the world, providing a rare freeze frame of ancient industrial techniques before they were silenced by the logistical reality of the Ming era. By examining the tool marks left in the channels, researchers have determined that the work was done in shifts, with different teams of stonecutters working on different sections of the monoliths simultaneously. The uniformity of the marks suggests a standardized training for Ming stonecutters, yet even this level of organization couldn't overcome the physical mass of the stone. The Yangshan Stele stands as the largest failed engineering project in history, proving that the ability to manipulate and move stones of this magnitude is a specific branch of science that does not necessarily advance linearly with time. Standing alone on the eastern tip of the island of Tongatapu is a structure that challenges every assumption about the technological limits of Pacific Islanders. Known as the Ha'amonga a Maui, or the Burden of Maui, it is a massive trilithon composed of 3 coral limestone slabs. 2 upright pillars support a horizontal lintel, which is locked into place using deep, hand-carved mortise and tenon joints. The structure stands approximately 17 feet high and weighs an estimated 30 to 40 tons. Often referred to as the Stonehenge of the Pacific, it represents a level of megalithic masonry that seems entirely out of place on a remote island where the primary construction materials were traditionally timber, palm fronds, and thatch. The official archaeological timeline attributes the construction to Tuitatui, the 11th king of the Tui Tonga Empire, around 1200 AD. This era marked the height of the Tongan Maritime Empire, a period when the kings of Tonga exerted influence over a vast swath of the Pacific, including parts of Fiji, Samoa, and the Cook Islands. However, the legends of the Tongan people offer a different perspective. Oral tradition claims that the stones were not local, but were brought across the ocean from Wallis Island by the god Maui. While mainstream history dismisses the supernatural element, the logistical implication of the legend that these stones traveled over 500 miles of open water highlights a significant construction paradox that archaeologists are still trying to solve. The technical challenge of the Ha'amonga a Maui begins with the geology of the island. Tongatapu is a flat coral limestone island with very little elevation. If the stones were quarried locally, as mainstream history suggests, they would have been extracted from the coastal reef flats about a mile away from the final site. However, moving 30-ton blocks across a tropical island presents an engineering nightmare. Unlike the dense forests of Europe or the cedar groves of Lebanon, Tongatapu lacked the large, straight-trunked timber required to create heavy-duty rollers. Furthermore, the terrain is composed of soft volcanic soil and sandy sediment. Under the weight of a 30-ton block, any makeshift wooden rollers would be driven into the earth, effectively grounding the stone. The engineering precision of the trilithon is often overlooked in favor of its sheer size. The lintel is not simply balanced on top of the pillars, it is recessed into them. The builders carved deep slots into the tops of the uprights to ensure the crossbeam could not slide or be dislodged by the frequent earthquakes or tropical cyclones that batter the region. This mortise and tenon technique is a hallmark of sophisticated masonry, usually found in timber framing or much more advanced stone cultures like those in ancient Egypt or Neolithic Britain. To achieve this in coral limestone, a material that is brittle and prone to shattering under uneven pressure, required a level of delicacy and planning that contradicts the image of a primitive island culture. The primary reason history may be wrong regarding the isolation and simplicity of the Tongan people lies in the structure's function as a solar observatory. In 1967, King Taufa'ahau Tupau IV proposed that the trilithon was more than just a gateway to the royal palace. He suspected it was a tool for celestial navigation. Investigations revealed that the lintel features specific incised marks that align perfectly with the sunrise on the summer and winter solstices. This alignment suggests that the 13th century Tongans possessed an advanced understanding of celestial mathematics. For a maritime empire, the ability to accurately track the solstices was not just a religious ritual. It was a matter of survival, as it allowed navigators to calibrate their stars and plan long-distance voyages across thousands of miles of featureless ocean. The archaeological context of the site, known as Heketa, shows that the trilithon was once part of a larger royal complex. Nearby, there is a large stone throne known as the Esimaka Fa Kinanga, which was used by the king. Legend says the king sat with his back to the stone to protect himself from assassins, while his long staff reached out to keep the commoners at a distance. The social structure of the Tui Tonga Empire was one of absolute monarchy and highly organized labor. The construction of the Ha'amonga a Maui would have required the mobilization of hundreds, if not thousands, of subjects. The coordination needed to quarry, transport, and lift these stones, likely using a system of earthen ramps and heavy sennit ropes made from coconut fiber, points to a society with an industrial-level capacity for organization. Despite the local quarry theory, the Wallis Island legend persists because it speaks to the Tongan mastery of the sea. If the stones were indeed transported by sea, it would mean the Tongan kalia were capable of carrying loads that modern wooden vessels would struggle to hold. A 30-ton block would require a barge or a catamaran system of immense displacement. While no such vessel has survived in the archaeological record, the mere existence of the trilithon suggests that our modern estimates of Tongan maritime load-bearing capacity are far too low. It implies that the Polynesians were not just drifters who found islands by luck, but were maritime engineers capable of moving megalithic weights across the largest ocean on Earth. The archaeology of the surrounding area has uncovered stone-paved paths and foundations that suggest the site was a hub of intense activity for centuries. Excavations have found pottery shards of the lapita tradition and stone tools made from basalt, which is not found on Tongatapu and must have been imported from volcanic islands like Samoa or Fiji. This confirms that the builders of the Ha'amonga a Maui were part of a high-traffic international trade network long before the first European ships arrived in the Pacific. They were part of a megalithic Pacific culture that treated the ocean as a highway rather than a barrier. The contradiction at the heart of the Ha'amonga a Maui is the same one we find at Stonehenge or Tiahuanaco. The tools of the time do not match the work of the time. The Tongan builders were officially in a late Stone Age or early Wood Age transition, yet they produced a monument that reflects the principles of structural engineering and solar astronomy. Why would a culture invest so much energy into a single stone structure if they were, as history suggests, perfectly capable of using timber? The answer likely lies in the desire for permanence. Stone was a way to anchor the empire to the earth and the sky. When we consider the maritime capabilities, the social organization, and the astronomical precision required to build the trilithon, the isolated islander narrative becomes impossible to maintain. The Ha'amanga of Maui is physical proof that the 13th century Tongan Empire was a sophisticated, technologically capable state that utilized megalithic science to cement its power. It suggests that our understanding of the Pacific's pre-contact history is missing a vital chapter, one where the kings of Tonga were not just masters of the waves, but masters of the stone as well. "600 miles south of the Great Pyramid of Giza, buried beneath the shifting sands of the Nubian Desert, lies a site that predates the pharaohs by nearly 5 millennia. Nabta Playa is a desolate, wind-swept basin where the summer heat often exceeds 120 degrees Fahrenheit. Today, it is one of the driest places on Earth, a wasteland of cracked earth and sun-scorched stone. But 9,000 years ago, this was a lush, seasonal savanna filled with deep lakes and wandering herds of cattle. It was here, in 7000 BC, that a group of nomadic people did something that mainstream history says should have been impossible. They built the world's oldest astronomical observatory. The hook of Nabta Playa is the staggering chronological gap it creates. While the Egyptian Old Kingdom was still 4,000 years in the future, the people here were already organizing massive blocks of sandstone into precise geometric patterns. They didn't just stand stones upright, they aligned them with a level of mathematical intent that suggests a deep, inherited knowledge of the cosmos. The centerpiece of the site is a small stone circle, barely 12 feet in diameter, but its simplicity is deceptive. This isn't just a basic calendar to mark the coming of the rains. It is a sophisticated map of the stars that tracks the most complex motion of our planet, the precession of the equinoxes. Precession is a phenomenon where the Earth's axis slowly wobbles, tracing a complete circle every 25,920 years. It is a movement so slow that it is virtually imperceptible to a single human lifetime, or even a dozen generations. To track it, a civilization needs to record the position of the stars with extreme accuracy over hundreds, if not thousands, of years. Yet, the stone alignments at Nabta Playa accurately track the position of the stars in the constellation of Orion and the bright star Sirius as they shifted across the horizon over millennia. It proves that these primitive cattle herders were not just watching the sky, they were calculating it. The archaeological discovery of Nabta Playa occurred almost by accident in the 1970s when a team led by Fred Wendorf noticed a series of standing stones protruding from the sand. What they found beneath the surface was an entire cult center dedicated to celestial observation. The site consists of several megalithic alignments, a series of complex stone structures known as tumuli, and the famous calendar circle. But who were these people? Mainstream archaeology refers to them as cattle herders, a nomadic group that migrated into the Sahara during the African humid period, when the desert was green. They were a people who relied on the arrival of the summer monsoon to fill the playa with water, making their cattle's survival dependent on the timing of the seasons. However, labeling them as mere nomads doesn't explain the sophisticated engineering found at the site. To create the calendar circle and the larger megalithic lines, they had to transport stones weighing several tons from distant outcrops. More importantly, they had to understand the true north and the cardinal directions without a compass. Some of the stones at Nabta Playa are carved into shapes that vaguely resemble cattle, while others are megalithic stelae that were intentionally buried in deep pits. This practice of burying stones after they were shaped is a direct link to the behaviors seen at Göbekli Tepe in Turkey, which predates Nabta Playa by only a few thousand years. This makes Nabta Playa the missing link in the story of civilization. It sits halfway between the 10,000 BC stone hills of Turkey and the 3000 BC rise of dynastic Egypt. For decades, historians struggled to explain how the Egyptians seemingly appeared out of nowhere with a fully formed understanding of astronomy, mathematics, and stonemasonry. Nabta Playa provides the answer. It shows that the foundations of Egyptian science were laid in the desert by a nomadic people who were forced to move toward the Nile Valley as the Sahara began to dry up around 5000 BC. The pharaohs didn't invent the Orion correlation or the worship of the celestial cow. They inherited it from the forgotten astronomers of the Playa. The engineering reality of the site is what truly challenges the traditional timeline. To align stones with the precision found at Nabta Playa requires more than just a keen eye. It requires a standardized system of measurement and a way to record data over long periods. If these people were truly nomadic, moving from lake to lake, how did they maintain the continuity of their observations? It suggests that they were part of a much more organized and settled society than we give them credit for. A green Sahara civilization that has been almost entirely erased by the encroaching sands. Why history is wrong becomes clear when we look at the mathematical implications of precession. To realize that the stars are shifting their position by only 1 degree every 72 years requires a culture that values long-term data. It pushes the start of civilization's intellectual peak back deep into the Ice Age. It proves that the human mind was already capable of high-level abstract thought and celestial mapping long before we had cities, written language, or the wheel. We are taught that the Neolithic Revolution was a slow transition from hunting to farming, but Nabta Playa suggests it was an era of intense scientific inquiry. The archaeology of the complex structures at the site reveals something even more unsettling. Excavations beneath some of the large stones found evidence of sacrificed cattle, but beneath others, there was nothing but a large, sculpted, physiographic stone, a rock that had been shaped by the builders to resemble something specific, then buried deep in the ground. This reflects a level of ritualistic planning that goes far beyond the needs of a survivalist nomadic group. They were treating the ground itself as a canvas for their astronomical map, anchoring the stars to the earth in a way that would survive for 10,000 years. Furthermore, the alignment of the stones at Nabta Playa is not just a near match. Computer models have shown that around 6000 BC, the stones pointed with surgical accuracy to the stars of the Big Dipper, Orion, and Sirius. This wasn't a primitive sundial, it was a cosmic clock. If the site was built in phases, as the archaeology suggests, it means that for over 2,000 years, different generations returned to this exact spot in the desert to update their map and refine their calculations. This kind of multi-millennial project requires a degree of cultural stability that mainstream history usually only attributes to the great empires of the Bronze Age. When we consider the environmental context, the feat becomes even more impressive. The Nabta people were living on the edge of a changing world. As the monsoon rains began to fail and the lakes began to shrink, their observation of the heavens likely became an obsession, a search for patterns in a world that was becoming increasingly unpredictable. Their ability to track the precession of the Earth may have been their way of trying to understand the long-term climate cycles that were eventually going to drive them out of the desert forever. The site remains one of the most important archaeological areas on the planet, not because of its size, but because of what it represents. It is a bridge across the great void of the Neolithic, connecting the high-tech stoneworking of the Ice Age to the dawn of recorded history. Rising out of the desolate Bolivian Altiplano, more than 12,500 feet above sea level, is a site that looks less like a ruin and more like a dismantled industrial complex. Tiahuanaco is home to the Ponce Monolith, an 11-foot-tall figure carved from deep red sandstone that stands as a silent witness to a technical mastery we still cannot fully explain. While at first glance it appears to be a typical ancient idol, a closer inspection reveals a surface covered in a dense geometric grid that mimics the complexity of a modern motherboard or an integrated circuit. In its hands, the figure grips two objects known as keros, yet their handles and slotted edges look remarkably like specialized mechanical tools rather than simple ritual vessels. The immediate problem facing archaeologists is the high-altitude environment. At over 2 miles above sea level, the air is thin, oxygen is scarce, and the physical effort required for heavy labor is immense. Yet, the specific red sandstone used for the Ponce monolith isn't found at the site. The nearest quarry is located miles away, across the treacherous and broken terrain of the Andes. Moving a multi-ton sandstone pillar through this landscape without paved roads or modern draft animals is a feat that defies traditional logistical models. It wasn't just a matter of muscle. It was about protecting the integrity of the stone, as sandstone is notoriously prone to fracturing under the uneven stress of being dragged or rolled. Turning our attention to the surrounding structures, the technical precision moves from impressive to impossible. A short distance from the monolith is the Puma Punku complex, famous for its H-blocks. These are massive blocks of sandstone and andesite that have been cut with such extreme accuracy they look like 3D printed modular components. They feature internal right angles, perfectly straight channels, and drill holes that are spaced with mathematical regularity. Many of these stones were designed to be held together by metal cramps, molten copper or bronze poured into pre-carved eye-shaped sockets. This is not the work of a culture limited to stone hammers. It is the evidence of a sophisticated, prefabricated assembly line. The precision of these H-blocks is the primary evidence that the mainstream timeline is missing something vital. When measured with modern squares, the internal angles of the cuts are perfect to within a fraction of a degree. Considering that andesite is a volcanic rock much harder than copper, it remains unclear how a culture supposedly lacking hardened steel or diamond-tipped tools could achieve such surgical cuts. To create a 90-degree internal angle in a stone, this hard requires a high-speed abrasive, or a cutting method that maintains constant, extreme pressure, technologies that history says did not exist in South America 1,000 years ago. The standard historical dating of 500 to 1000 AD has been heavily challenged by astronomical evidence found at the site. Arthur Posnansky, one of the most dedicated researchers of Tiahuanaco, observed that the Kalasasaya temple, where the Ponce monolith stands, was built as a massive solar clock. By calculating the alignment of the temple's cornerstones with the sun during the solstices, he discovered a slight but significant discrepancy with the current sky. Using the established rate of change for the Earth's axial tilt, Posnansky calculated that the temple was actually aligned to the sun as it appeared in 15,000 BC. This staggering date places the Ponce monolith and the surrounding city deep within the last ice age. It suggests that Tiahuanaco is not a late-period Andean culture, but a survivor of a much older, global peak in human capability. If the 15,000 BC date is accurate, it means the builders were master astronomers who understood the precession of the equinoxes and long-term celestial cycles. This level of mathematical data is not something that emerges from a simple agricultural society. It is the hallmark of a civilization that has been observing the heavens for thousands of years. The method of construction also points toward a lost science. Some material scientists have suggested that the builders didn't carve the stones at all, but rather used advanced geopolymer chemistry, essentially a form of liquid stone. By crushing local sandstone and mixing it with mineral binders, they could have poured the blocks into molds, explaining the perfect uniformity of the H-blocks and the fine printed details on the Ponce monolith. This would solve the logistical nightmare of moving massive stones through the thin mountain air, as the raw materials could have been transported in smaller, manageable bags before being cast on site. Alternatively, local Aymara legends speak of a celestial fire and a golden wedge that allowed the ancient builders to soften stone until it could be worked like clay. While this sounds like myth, the vitrified and glossy surfaces found on some of the joints at Tiahuanaco suggest the application of extreme heat. Whether they were using chemical polymers or thermal softening, the results are the same: a mastery of material science that we are only now beginning to replicate with modern industrial chemistry. The archaeology of the site also reveals that Tiahuanaco was once a major port on the shores of Lake Titicaca, which has since receded several miles. The remains of stone docks and canal systems suggest a high-altitude maritime empire that operated in a world where the geography looked very different than it does today. Excavations have also uncovered raised fields, a sophisticated agricultural technology that used water channels to regulate soil temperature, allowing crops to thrive in the freezing altiplano nights. This was a culture that didn't just survive in a harsh environment. They re-engineered it entirely. What makes the Ponce monolith so significant is the sense that it represents a missing chapter of human evolution. Its circuit-like patterns and mechanical tools suggest a society that was focused on the intersection of stone, frequency, and energy. Was it a depiction of a priest, or was it a commemorative statue of the engineers themselves holding the tools that allowed them to turn a mountaintop into a stone machine? In many traditions, these gods are credited with bringing the arts of civilization to a primitive world. Looking at the monolith, it feels as though we are seeing a portrait of those teachers. To understand the true nature of the Giza Plateau, you have to look past the sheer scale of the Great Pyramid and focus on the ground beneath your feet. Scattered across the basalt and granite paving stones of the plateau are artifacts that the mainstream archaeological record struggles to explain. These aren't golden idols or intricate statues, but something far more revealing: industrial waste. We are looking at drill holes and saw cuts in rose granite, one of the hardest materials on Earth, that exhibit characteristics of high-speed mechanical machining. If you ignore the legends and simply look at the physics of the stone, the Giza Plateau ceases to be a primitive tomb and starts to look like a high-tech construction site that was suddenly abandoned. The mechanical evidence is etched directly into the rock in the form of spiral grooves found inside hollow drill holes. When a modern core drill penetrates a material, it leaves a helical trail known as a feed rate, which measures how deep the drill sinks into the material with every single rotation. In 1883, Sir Flinders Petrie, the father of modern Egyptology, conducted a rigorous survey of these cores and came to a conclusion that still haunts the field. He observed that the spiral grooves in the Giza granite were cut with such immense pressure that the drill was sinking into the rock 500 times faster than a modern diamond-tipped drill could achieve today. Petrie was no theorist. He was a meticulous surveyor, and his measurements revealed a level of force and speed that would have instantly shattered any copper tool. The Petrie observation remains the single most significant piece of evidence for lost technology in Egypt. In his own 19th century notes, Petrie admitted that the sheer efficiency of these cuts could only be explained by jeweled saws and drills that operated under thousands of pounds of downward pressure. He noted that the grooves were not just scratches, but deep, continuous channels that spiraled down through the granite without breaking. To achieve this, the cutting edge of the drill would need to be harder than the granite itself, and the motor, or whatever was driving the bit, would have to be powerful enough to maintain a constant torque against incredible resistance. This is the definition of power tool technology appearing in the 3rd millennium BC. Why the traditional historical narrative is wrong becomes a matter of simple material science. The official explanation provided to the public is that the Egyptians used copper saws and tubes combined with an abrasive-like quartz sand to slowly wear through the granite. While it is true that sand and copper can eventually grind through stone, it is a slow, tedious process that leaves a smooth, buffed surface. It absolutely cannot produce deep, consistent spiral grooves with a rapid feed rate. The abrasive slurry method is a grinding process, not a cutting one. What we see at Giza is a high-speed penetration of the material that bit into the stone and moved through it with the ease of a modern industrial press. The scale of this operation is also overlooked. We aren't just talking about 1 or 2 holes. We are talking about hundreds of core-drilled samples and thousands of feet of saw cuts. In the basalt paving stones near the base of the Great Pyramid, you can find run-out marks where a circular saw overcut its mark. These saw marks show a blade diameter of several feet, moving through the rock with a precision that leaves the surface perfectly flat. When you examine these marks under magnification, the striations remain parallel and even, which only happens when the cutting tool is fixed to a rigid, mechanical frame. A handheld copper saw, operated by two men, would inevitably wobble, creating uneven grooves and varied depths. The Giza marks are as consistent as a factory-line product. The logistical math of the Old Kingdom further complicates the sand and copper theory. To cut the millions of cubic feet of granite used in the pyramids, and the surrounding temples using only hand tools and sand would require more copper than was likely mined in the entire ancient world. The wear and tear on copper tools is extreme. For every inch of granite cut, several inches of copper are lost to friction. This would create a staggering demand for metal and a massive industrial byproduct of copper-enriched sand, neither of which has been found in the archaeological record in the quantities required. Instead, the evidence points toward a much more efficient, possibly point-contact cutting technology that minimized tool wear while maximizing speed. The location of these artifacts, scattered across the Giza Plateau and inside the king's chamber, suggests that this technology was the standard, not the exception. Inside the Great Pyramid, the granite coffer shows signs of being hollowed out using these same large-scale core drills. You can still see the places where the drill bits overlapped and where the saw cut too deep into the corners. It's as if we are looking at a finished product that still bears the pencil marks of its mechanical creator. The builders were in such a hurry or were so confident in their tools that they didn't bother to polish out the evidence of the machines they used. The archaeology of the Old Kingdom often focuses on the who and the when, but it rarely addresses the how from a mechanical engineering perspective. For a long time, the lack of iron or steel in the archaeological record was used to prove that the Egyptians must have used copper, but this ignores the possibility of a different branch of technology. Just as we have moved from mechanical saws to lasers and water jets, the smoking gun at Giza suggests the Egyptians utilized a form of energy or a material science that we have yet to rediscover. Whether it was sonic drilling, high-frequency vibration, or a lost alloy that was harder than diamond, the physical result is etched into the granite for anyone to see. Sir Flinders Petrie himself was so disturbed by the implications of the core drills that he speculated about the use of emery or corundum fixed into the teeth of the saws. But even with those abrasives, the feed rate remains the impossible variable. You can have the hardest teeth in the world, but if you don't have the mechanical force to push them into the stone, you won't get those deep spiral grooves. The Stone Age label for this period is effectively a misnomer. You cannot produce industrial-grade machining without an industrial-grade infrastructure to support it. The core drills prove that history is not a slow, linear climb from primitive to advanced. Instead, it seems we are looking at a peak of technology that occurred early in the Egyptian story and then gradually faded away. The later dynasties never replicated the precision or the speed of the Old Kingdom builders. By the time of the New Kingdom, the ability to cut granite with this level of mechanical efficiency was already a memory. The Giza Plateau is effectively a graveyard of a high-tech civilization, where the tombstones are the very machines and tools that built it. In the quiet rolling landscape of County Carlow, Ireland, sits a structure that changes our understanding of Neolithic logistics through its sheer, concentrated mass. Unlike the sprawling complexes of Stonehenge or the Great Pyramids, the Brownshill Dolmen is a singular, isolated event. It consists of a few upright stones supporting a massive granite capstone that currently sits at a tilted angle, one end resting on the ground and the other propped up by vertical pillars. While it might look like a simple prehistoric tomb, the numbers associated with this site move it out of the realm of primitive construction and into a category of engineering that we still struggle to quantify. The primary feature of Brownshill is the capstone itself. Carved from a single piece of local granite, it is estimated to weigh between 100 and 150 tons. This makes it the heaviest megalithic capstone in Europe, and potentially one of the heaviest ever lifted in the prehistoric world. To put 150 tons into perspective, you are looking at the weight of a fully loaded blue whale, or approximately 100 mid-sized cars. In the modern world, if a construction crew needed to lift a 150-ton granite slab to a height of 6 feet, they would call for a multi-million-dollar mobile crane or a specialized hydraulic jacking system. In 4000 BC, however, the builders supposedly accomplished this using nothing more than raw human muscle, timber, and earth. The mainstream historical explanation for how such a feat was achieved usually involves the dirt ramp theory. The idea is that the upright stones were placed in a pit, and then a massive earthen ramp was constructed leading up to the top of those stones. The capstone would then be dragged up the ramp by hundreds of laborers using ropes and wooden rollers. Once the stone was in place, the dirt was cleared away, leaving the dolmen standing. While this sounds plausible in a textbook, when you apply basic physics and material science to a 150-ton load, the theory begins to face significant mechanical hurdles. First, we have to look at the rollers. To move 150 tons across a soft Irish landscape, you would need timber rollers of incredible density, likely oak or yew. However, the pressure exerted by 150 tons on a few points of contact is immense. Under that kind of weight, the fibers of the wood would likely be crushed into pulp, or the rollers would simply be driven deep into the dirt of the ramp, effectively grounding the stone. To prevent this, the road beneath the rollers would need to be paved with stones or reinforced with a secondary layer of timber, creating a construction project that is actually larger and more complex than the dolmen itself. Then, there is the math of the pull. If we assume a modest 10-degree incline for the ramp, the force required to move 150 tons up that slope is staggering. In a 4000 BC context, the only rope available would have been made from braided plant fibers or animal hide. The tensile strength of organic rope is limited. To pull 150 tons, you would need a cable so thick it would be nearly impossible to wrap around the stone, and even then, the friction and tension would likely cause the rope to snap long before the stone moved an inch. Even if the ropes held, you would need upwards of 800 to 1,000 men pulling in perfect synchronization. Finding the physical space for 1,000 men to pull on a narrow ramp is a logistical nightmare that traditional archaeology rarely addresses. The archaeology of the Brownshill site reveals that the capstone was likely quarried very close to where it stands today, which solves the problem of long-distance transport, but does nothing to explain the vertical problem. The stone isn't just sitting there, it was lifted. The precision required to balance 150 tons on 3 or 4 vertical points is extreme. If the weight isn't distributed perfectly, the uprights will tip or shatter under the uneven pressure. This suggests that the Neolithic builders had a sophisticated understanding of center of gravity and structural load bearing, concepts we usually associate with much later architectural traditions. One of the most interesting aspects of the Brownshill dolmen is the lack of ancillary evidence. If there were massive ramps and thousands of workers, we should find evidence of large-scale worker camps, massive amounts of discarded tools, or the remains of the ramps themselves. Instead, the dolmen often appears in the landscape as a solitary monument. This leads to the possibility that the builders didn't use brute force at all. Some researchers suggest they utilized a more refined mastery of leverage and friction, perhaps using a series of small, incremental lifts with levers and wooden cribbing to jack the stone up an inch at a time. This would require far fewer men, but a much higher level of engineering intelligence. Why history is likely wrong in its assessment of these people as primitive is found in the longevity of the structure. Brownshill has stood for 6,000 years. It has survived centuries of Irish weather, seismic shifts, and human interference. The fact that the stones haven't shifted or collapsed under the massive weight of the capstone proves that the foundations were dug and reinforced with a long-term vision. These weren't nomads throwing stones together. These were engineers building for eternity. The existence of Brownshill alongside other massive Irish dolmens like Proleek or Polnabrone suggests a global megalithic science that was prevalent across Europe during the Neolithic. We see the same principles of moving and lifting massive stones in Brittany, Spain, and Malta. This implies a shared body of knowledge regarding the manipulation of mass that doesn't seem to have a clear origin point in the archaeological record. It appears suddenly reaches a peak of massive stone movement and then slowly transitions into smaller, more manageable construction styles. In a professional documentary context, Brownshill is often overlooked because it isn't as flashy as a pyramid, but from a physics perspective, it is arguably more impressive. It represents the maximum limit of what can be done with organic materials and human labor. If 150 tons truly represents the ceiling of Neolithic capability, then the people of County Carlo reached that ceiling 6,000 years ago. They proved that you don't need iron or electricity to dominate your environment. You just need a perfect understanding of the lever and the wedge. The archaeology of the site continues to be studied, but much of the area remains unexcavated to preserve the integrity of the monument. What we do know is that the site was likely a focal point for the community for centuries, a place of burial, ritual, or perhaps a boundary marker. In the southern reaches of the Kemerovo Mountains in Siberia, a discovery has emerged that threatens to break every existing record of human engineering. Gornaya Shoria is home to a series of granite walls that feature some of the largest individual stones ever documented. While the world marveled at the 800-ton blocks of Baalbek or the 1,000-ton stone of the pregnant woman in Lebanon, those megaliths are effectively dwarfed by the Siberian titans. Some of the granite blocks stacked at Gornaya Shoria are estimated to weigh upwards of 3,000 tons, masses so significant that modern industrial cranes would be incapable of lifting them in their current environment. The scale of these stones is only the beginning of the anomaly. The walls reach heights of 130 feet, with the blocks stacked in a manner that resembles traditional masonry. They feature sharp 90-degree angles and flat faces that fit together with consistent seams stretching for hundreds of feet across the mountain ridge. If these are truly man-made, they represent a level of heavy lift capability that implies a total mastery over gravity and friction, existing in a region that history tells us was populated only by nomadic hunter-gatherers. Mainstream geology currently categorizes Gornaya Shoria as a product of orthogonal jointing. This natural process occurs when granite, cooling deep underground, contracts and cracks along specific planes of weakness. Over millions of years, tectonic uplift and frost weathering can widen these cracks, creating blocks that look remarkably like they were cut by human hands. Geologists argue that the walls are simply the exposed bedrock of the mountain, eroded into rectangular shapes by the harsh Siberian elements. However, several archaeological features at the site make the purely natural theory difficult to sustain. While nature can produce 90-degree cracks, it rarely produces the complex, interlocking patterns found in several sections of the Shoria walls. Researchers have identified blocks that appear to be placed in a header and stretcher orientation, a standard construction technique used to increase the structural stability of a wall by alternating the long and short sides of the stones. Nature does not typically stack 3,000-ton blocks in a mathematically sound defensive pattern. Furthermore, physical evidence on the stones themselves points toward an artificial origin. Close-range inspections of some granite surfaces have revealed burnt textures and scorch marks that are not consistent with the surrounding natural rock. These marks suggest the application of intense concentrated heat, similar to the vitrification seen in Scottish forts or the thermal drilling patterns found at Giza. In some areas, the granite appears to have been slightly melted or softened, a phenomenon that orthogonal jointing cannot account for. There are also clear, deep channels cut into the stones that look like tool marks, grooves that maintain a consistent depth and width across multiple blocks, suggesting a mechanical tool was moved across the face of the wall after it was already assembled. The geopolitical context of Gornaya Shoria is perhaps the reason it remains largely unknown to the Western world. Siberia has long been subject to an archaeological blackout, partly due to its extreme remoteness and partly due to the Soviet-era focus on industrial and military development over cultural research. The site is located in a high-altitude region that is only accessible for a few months out of the year, requiring a multi-day trek through dense taiga and mountain passes. Until recently, Russian archaeology was largely isolated from international peer review, meaning that massive anomalies like Gornaya Shoria were often dismissed as local curiosities rather than global game changers. When you analyze the logistical reality of the site, the natural theory begins to feel like a placeholder for a lack of better answers. To move a 3,000-ton block in the modern day, we would require a specialized crawler transporter like those used by NASA, and even then, we would need a perfectly level, reinforced concrete road. Gornaya Shoria is situated on a mountain ridge with steep gradients and uneven terrain. There is no infrastructure, no flat ground, and no logical way a primitive culture could have dragged these stones into place using ropes and rollers. The pressure exerted by 3,000 tons would crush any timber roller into pulp and sink any sled deep into the soil. If we accept the possibility that these are man-made, it forces a radical reassessment of the human story. It would mean that a civilization existed in northern Asia, potentially during the height of the last glacial maximum, that operated on a scale of power we haven't even dreamed of. This Siberian peak would have occurred in a region that was supposed to be an Ice Age wasteland, suggesting that either the climate was different or the builders possessed technology that made the environment irrelevant. The site also features magnetic anomalies that are concentrated specifically around the masonry sections of the walls. Compasses used by research teams have been documented spinning wildly or reversing their polarity when brought close to certain blocks. While this can happen in nature if a rock has a high magnetite content, it is rare for such readings to be confined strictly to a stacked formation, while the surrounding bedrock remains magnetically neutral. This has led to speculation that the walls may contain internal technological components, or were treated with a process that altered the magnetic signature of the granite itself. Another overlooked detail is the presence of passageways and gates that have been cut through the megalithic stacks. These openings feature vertical sides and horizontal lintels that follow the same geometric precision as the rest of the wall. Natural erosion is random and chaotic. It does not produce a 10-foot-tall rectangular opening with a flat roof in the middle of a massive stone wall. These features suggest intentional design for access, ventilation, or perhaps as part of a larger, more complex interior chamber system that has yet to be explored. The Wayu behind Gornaya Shoria remains the most significant vacuum in the narrative. The local indigenous people, the Shors, have legends of ancient giants who built the walls, but there is no archaeological record of a sedentary, high-tech culture in this part of Siberia. We find the remains of the Denisovans and early modern humans, but their toolkits are limited to stone scrapers and bone needles. There is a massive technological gap between the people we know lived there and the work that exists on the mountain. This implies the existence of a ghost civilization, a culture that left behind its largest monuments, but none of its smaller, portable history. Why history is wrong about Gornaya Shoria is ultimately a matter of scale. We are taught to look for the cradle of civilization in the fertile river valleys, like the Nile or the Indus. We are told that civilization requires agriculture, surplus food, and large populations. But Gornaya Shoria suggests that a mastery of stone and energy could have emerged in the most unlikely of places. It proves that the megalithic secret wasn't restricted to a specific region or climate. If these blocks were stacked by hand, then the people of northern Asia were the undisputed kings of the ancient world, moving weights that the Egyptians and the Romans wouldn't have even attempted. The archaeology of the site is still in its infancy. Systematic excavations at the base of the walls are needed to search for tools, organic debris, or foundations that could provide a firm date. On the small island of Malta, historians are dealing with an engineering puzzle that predates the Egyptian pyramids and Stonehenge by over 1,000 years. The landscape is dotted with unique clover-leaf-shaped temples, like Hagar Chim and Menajdra, built using limestone blocks that weigh upwards of 50 tons. Inside these structures, archaeologists have found the Fat Lady statues, rounded, faceless figures that suggest a culture deeply focused on biology and the earth. However, the most significant evidence of advanced ancient science is located 11 meters underground in the Hal Saflieni hypogeum. This is a 3-story subterranean complex carved directly into the bedrock with a level of precision that suggests it was much more than a simple burial site. The story of the island's discovery took a major turn in the early 20th century. In 1902, workers digging a cistern for a new housing development in the town of Paula accidentally broke through the roof of the hypogeum. What they found was a staggering multi-level complex that had been hidden for thousands of years. Excavations eventually revealed that the site was carved starting around 4000 BC, making it one of the oldest and most complex underground structures on the planet. The builders didn't just hollow out random caves. They replicated the architectural styles of the temples found on the surface, carving fake beams, curved ceilings, and formal doorways into the solid limestone. Mainstream archaeology dates the start of this temple period to roughly 3600 BC. The main technical mystery here is the total lack of a developmental phase. The archaeological record shows simple farmers living on the island around 5000 BC. But then, without any clear intermediate steps, the Maltese began moving stones the size of small houses. Moving a 57-ton slab of limestone across the jagged coastal terrain of Malta requires a sophisticated understanding of friction and balance. Yet the only tools found from this period are basic flint scrapers and stone balls used as rollers. This creates a massive gap between the simple tools and the industrial scale of the buildings. The Hal Saflieni hypogeum serves as the primary evidence for what looks like lost acoustic technology. The complex was carefully carved into the limestone to mirror the surface temples. One specific area, known as the Oracle Room, contains a small, hand-carved niche that acts as a resonator. When a low-pitched sound is made in this niche, it vibrates through the entire stone complex. Scientific testing by independent researchers has confirmed that these chambers are tuned to resonate at exactly 110 Hz. This specific frequency is likely not a coincidence. In modern brain studies, 110 Hz has been shown to temporarily change activity in the human brain, shifting it toward a more meditative state. The builders of the hypogeum were effectively practicing a form of acoustic engineering. They used the natural density of the limestone and the specific shape of the rooms to create a space that could physically affect the people inside. This implies a mastery of sound physics that we usually don't attribute to ancient farmers. They were using the earth itself to turn the human voice into a physical force. The identity of the people behind these structures is tied to local folklore that was recorded long before modern archaeology existed. Legends in Malta attribute these megaliths to a race of giants. One story tells of a giantess named Sansuna, who supposedly carried the massive stones of Gantija from a distant quarry while living on a diet of wild honey. While these stories are often seen as myths, the recurring theme of giants in almost every megalithic culture on Earth, from the Andes to the Pacific, points toward a collective memory of a time when these massive stones were moved with an ease that seemed superhuman to later generations. It suggests a memory of a specific technology that allowed people to manipulate massive weights before that knowledge was lost. The astronomical data at sites like Menajdra makes the timeline even more interesting. The temple entrances are aligned so that on the spring and autumn equinoxes, the rising sun sends a beam of light directly through the center of the building to light up a specific altar. During the solstices, the light aligns with the edges of the stones with total accuracy. This level of solar tracking requires a standardized way of measuring time and a recorded history of the stars that spans many generations. It suggests a Mediterranean civilization that possessed a shared, advanced body of knowledge rather than an isolated island culture. Some researchers point to the cart ruts as evidence that Malta was part of a larger, now submerged landscape. Thousands of parallel tracks are carved into the limestone bedrock across the island, and many of them lead directly off cliff edges and continue for hundreds of yards along the seafloor. These ruts show no signs of animal wear or human footprints between the tracks. Their continuation underwater suggests they were carved when the sea level was much lower, likely at the end of the last ice age. This would push the activity in Malta back several thousand years, to a time when the Mediterranean was a series of dry basins and land bridges. The geology of Malta also plays a role in this mystery. The local limestone is relatively soft when first dug up, but hardens significantly once it is exposed to the air. This might explain how the builders were able to carve the intricate textures into the walls of the hypogeum. However, it doesn't explain how they maintained perfect symmetry over 3 floors of underground construction. To carve a vertical shaft 11 meters deep while making sure the oracle room stays perfectly tuned to 110 hertz suggests the builders were working from a very specific plan. They knew exactly how much stone to remove to get the right sound before they ever started digging. The archaeology also shows a strange lack of weapons or fortifications during the temple period. Instead, the focus was entirely on art, architecture, and the science of sound. This peaceful society existed for over 1,000 years before it suddenly vanished around 2500 BC. The cause of their disappearance is still unknown, but some evidence points to a sudden ecological change or a rise in sea levels that might have isolated the island until the civilization could no longer support itself. When European researchers first visited the site in the 1800s, they were fascinated by the fat lady statues found in almost every temple. These figures depict humans with very rounded limbs and bodies. Some argue these weren't just goddesses, but representations of the physical state people entered while inside the acoustic chambers. Others point to the sleeping lady found in the hypogeum, a small, perfectly carved woman lying on a bed, as evidence that the site was used for deep meditation or dream work. This society wasn't focused on war or conquest, but on the science of the human mind. The Hagar Kim complex features a single stone that is 7 meters long and weighs about 57 tons. In 3600 BC, the logistics of standing this stone upright without modern cranes is a massive challenge. The stone is sitting on a plateau overlooking the sea, exposed to high winds and erosion. The fact that it has stayed standing for over 5,000 years proves that the builders understood foundation engineering. They didn't just place stones on the ground. They anchored them into the bedrock using sockets and paving stones to make sure they wouldn't shift over time. Ultimately, the temples of Malta provide a record of a society that treated stone and sound as 2 parts of the same technology. The 110 hertz resonance of the hypogeum and the 50-ton stones of Hagar Kim are physical proof that over 5,000 years ago, a culture was already mastering principles of physics that we are only now starting to understand again. Malta wasn't just a remote outpost. It was a center for a sophisticated tradition that used the earth itself to bridge the gap between building materials and human biology. High in the rugged plains of southeastern Turkey, a region known as the Stone Hills is fundamentally shifting our understanding of the deep past. While the world spent the last decade focused on Göbekli Tepe, a nearby site called Karahan Tepe has emerged as an even more complex piece of the puzzle. Dating back to at least 10,000 BC, this sprawling complex was carved directly into a limestone ridge, featuring hundreds of upright pillars and subterranean rooms that suggest a level of organization once thought impossible for the end of the last ice age. The most striking discovery within this stone landscape is a sunken, rectangular space often referred to as Structure AB. Here, the builders didn't just bring in stones from a quarry. They carved 11 upright, phallic pillars directly out of the living bedrock, leaving them attached to the floor. Watching over this chamber is a large, realistic human head carved into the western wall. The face is stoic, with a prominent nose and thick lips, positioned to stare directly across the room. During the winter solstice, a small window allows the sun to enter and illuminate this face, creating a theatrical play of light that seems remarkably advanced for a culture that supposedly hadn't even discovered agriculture yet. Comparing this to Göbekli Tepe reveals a different artistic intent. While Göbekli Tepe is famous for its animal carvings, vultures, scorpions, and foxes, Karahan Tepe is much more focused on the human form. There are over 250 T-shaped pillars across the site, but here, the carvings are often three-dimensional and integrated into the architecture. You can see human figures carrying animals or faces emerging from the stone. The floors are leveled and polished with a precision that makes the Stone Age label feel like a massive understatement. This wasn't a place for living. It was a sophisticated ritual center that required thousands of people to coordinate their efforts and follow a unified architectural plan. Karahan Tepe confirms that the high-tech stonework of this region wasn't an isolated event. It was part of what researchers now call the Tas Tepeler culture, a regional network of stoneworking and astronomical observation that functioned 6,000 years before the first city-states of Mesopotamia. These people were dedicating millions of man-hours to carving mountains and mapping the stars. They had mastered the geometry of the circle and the physics of the lever long before they were even farming. The scale of the work, covering nearly 325,000 square feet, implies a society with a clear hierarchy and specialized workers who knew how to peel layers of limestone away to create massive standing structures. Perhaps the most fascinating aspect of Karahan Tepe is how it was handled when the builders were finished with it. Like many of the sites in this region, the entire complex was intentionally buried around 8000 BC. They didn't just leave it to the elements, they backfilled the chambers with hundreds of tons of clean soil and rubble, even placing flat stones over the mouths of the pits to protect the carvings. This act of ritual burial preserved the site for over 10,000 years. It suggests they viewed the site as something that needed to be put to rest or protected from a major change in the world. Our exploration of these 10 sites, from the mirror-polished caves of India to the 3,000-ton blocks of Siberia and the 12,000-year-old pillars of Turkey, leads to a single, unavoidable conclusion. The history of humanity is not a slow, linear crawl from the cave to the computer. Instead, it is a cycle of magnificent peaks, followed by sudden, often violent, resets. We have seen evidence of high-speed mechanical drilling at Giza, advanced acoustic engineering in Malta, and logistical feats in China and Ireland that defy the laws of physics as they were supposedly understood at the time. If you enjoyed this deep dive into the hidden history of our world, please consider liking the video and subscribing to the channel. It helps us keep the lights on and the expeditions going. Thanks as always for watching. This has been Uncharted Mysteries, and as always, until next time, stay curious.